Our planet's climate is a web of connections, where a shift in one region can echo across the globe. One of the most striking examples is La Niña, a natural climate pattern that begins in the Pacific Ocean. During La Niña, strong winds push warm surface water westward, away from South America, allowing colder water to rise up from the deep, a process called upwelling. This creates a vast area of unusually cool water in the eastern and central Pacific, a change that can last months or even years. But this isn't just a local event. The cooling triggers a chain reaction in the atmosphere, altering global weather patterns. The Pacific acts as a giant engine for our planet's weather, and when its surface cools, it changes the air above, making it cooler and drier. This disrupts the normal flow of powerful air currents, like the jet stream, which steer weather systems around the world. La Niña nudges these atmospheric rivers onto new paths, spreading its influence far beyond the Pacific. In simple terms, La Niña is a big chill in the tropical Pacific that sets off a global domino effect. It's a natural recurring event, one half of the El Niño Southern Oscillation, or ENSO. While it starts quietly in the ocean, its impact is anything but silent. La Niña orchestrates changes in weather patterns across continents, including Europe. Understanding La Niña is key to understanding our own winter weather. It's not caused by humans, but climate change may be affecting how often and how strongly it appears. This little girl in the Pacific is a powerful conductor of global climate. Let's see how her influence reaches all the way to Europe. How does a cooling in the Pacific affect winter in Europe? The answer lies in the jet stream, a fast-flowing river of air that separates cold polar air from milder southern air. La Niña alters the jet stream's path, making it wavier and more prone to deep troughs and ridges. This waviness is crucial. It allows cold Arctic air to spill south into Europe. The result is often a negative North Atlantic oscillation, or NAO, with weaker westerly winds. Instead of mild Atlantic air, Europe gets more frequent blasts of frigid, dry air from the east and northeast. The mechanism is a complex dance of atmospheric pressure and wind patterns over the North Atlantic. La Niña's initial trigger in the Pacific sets off a cascade of changes that ultimately shape Europe's winter. It's a vivid example of how distant climate events can have local consequences. The jet stream is the bridge, carrying La Niña's influence across continents. This is how a chill in the Pacific can mean a deep freeze in Europe. When La Niña is active, Northern Europe, places like the UK, Scandinavia, and Germany, faces a higher risk of cold, dry winters. The wavy jet stream and negative NAO open the door for Arctic air, especially from January to March. Instead of mild, damp winters, these regions can see bitter cold and clear skies, with less precipitation overall. Blocking high-pressure systems can lock in these conditions for weeks, diverting milder weather away. The result: prolonged frost, ice, and disruptive snow events. While not guaranteed every year, La Niña stacks the odds for a more traditional, old-fashioned winter. It's a signal to prepare for snow, ice, and a real winter chill. The atmosphere is chaotic, but La Niña tips the balance toward colder, drier weather in the north. While the north freezes, southern Europe often gets wetter and stormier during La Niña. The jet stream dips south, steering storms across Spain, Italy, and Greece. This brings heavy rain and mountain snow, replenishing reservoirs and rivers. The extra precipitation is vital for agriculture and water supplies, but it can also mean flash floods and landslides. The Mediterranean winter shifts from dry and mild to wet and turbulent. La Niña's impact is a double-edged sword: relief from drought, but a higher risk of severe weather. The region's entire winter character can change, for better and for worse. History shows La Niña's powerful mark on Europe's winters. The winter of 2010-2011 in the UK, following a strong La Niña, brought record cold and heavy snow, paralyzing transport and daily life. In 2008-2009, Northern Europe again saw a colder than average season, while Spain enjoyed much-needed rain. This north-south contrast is a classic La Niña signature. Scientists have traced La Niña's influence back centuries, using tree rings and ice cores to link harsh winters to Pacific cooling. Even during the Little Ice Age, persistent La Niña-like conditions contributed to Europe's frigid winters. Not every La Niña is the same. Other climate factors can override its effects. But when La Niña is strong, the odds of a cold north and wet south in Europe rise sharply. The historical record confirms La Niña is a powerful force in shaping our winters. Its fingerprints are found throughout Europe's climate history. To understand La Niña, meet its sibling, El Niño. Both are faces of the El Niño Southern Oscillation, or ENSO. La Niña cools the Pacific. El Niño warms it. During El Niño, weakened trade winds let warm water surge east, heating the central and eastern Pacific. This flips the script for Europe. El Niño often strengthens the jet stream, keeping Arctic air at bay and bringing milder, wetter winters to the north. Southern Europe, meanwhile, can turn drier, raising the risk of winter drought. La Niña and El Niño create nearly opposite winter patterns for the continent. By comparing their impacts, scientists better understand how the Pacific shapes Europe's weather. La Niña pulls the jet stream south, cold north, wet south. El Niño pushes it north, mild north, dry south. Knowing which sibling is in charge is crucial for long-range winter forecasts. La Niña's winter shifts have real consequences for Europe. Farmers in the north risk crop damage and delayed planting from deep freezes, while southern growers may benefit from rain or suffer floods. Energy demand spikes in cold northern winters, straining power grids and raising costs. Transport networks face disruption from snow and ice, while cities in the south must brace for flooding. For individuals, it means preparing homes, travel plans, and even healthcare for the season's risks. Hospitals see more respiratory illnesses during cold snaps. Governments and businesses use La Niña forecasts to plan for energy, supplies, and emergencies. Awareness is key. Understanding La Niña helps everyone manage risk. The Pacific's little girl shapes daily life, economy, and safety across Europe each winter. Ignoring her influence isn't an option for a resilient society. How do we know when La Niña is coming? Scientists use a global network of satellites, buoys, and ships to monitor the Pacific. The Tau array of buoys tracks ocean temperatures and winds in real time. Satellites measure sea surface height and temperature, revealing the cool water signature of La Niña. All this data feeds into powerful climate models, which simulate how the atmosphere and ocean will evolve. These models help meteorologists issue seasonal forecasts months in advance. Agencies like the Met Office and ECMWF use this information to predict if winter will be colder, warmer, wetter, or drier than usual. While exact daily forecasts are impossible months ahead, these seasonal outlooks are vital for planning. La Niña's global monitoring is a triumph of modern science, helping society prepare for what's ahead. Knowing La Niña is coming gives us a chance to prepare. In Northern Europe, check home insulation, service your boiler, and stock up on winter essentials. Prepare your car with emergency supplies and consider winter tires for safety. In the south, focus on flood prevention, clear drains, have an emergency plan, and stay alert to warnings. Simple steps, like lagging pipes or securing outdoor furniture, can make a big difference. Follow seasonal forecasts to understand your region's risks. Preparation is about awareness and action, not fear. By listening to climate signals, we can protect our homes, health, and communities. La Niña's influence is powerful, but with knowledge and planning, we can weather the winter safely.